Mine is in my lockers. I think mine's
Okay, for probably the next week, we are going to be doing what's called systems of equations. Okay, and really that is nothing more than you're going to be given two linear equations and finding the answer that they both have. Okay, basically taking two linear equations and finding their answers, and finding what one numbers solve both. And you'll kind of get it, I hope, after this, maybe not. I guess it doesn't really matter. Here is my first, for example. Let's say I said to you, you have two numbers whose sum is 12. Now, first things first, how would I write an equation to stand for that? Two numbers, when you add them together, their sum is 12. You don't know what they are, but Holly?
A plus B equals 12.
Perfect. But instead of A plus B, I'm going to go with X and Y's because we use X and Y's a little bit more. So X plus Y equals 12. Okay? Got that? If I were to graph this, by the way, what form is that? Standard form. If you were to graph this, X equals 12, Y equals 12, you draw your straight line. You draw your straight line through 12 and 12. Nice straight line I have there. And what you will realize is that
It makes them try.
no, it's a good thought though.
It makes the right wrong part
Well,
of that.
what this line stands for is all the possible answers to that equation. Okay, if you look at this, okay, you could have X be 0, Y be 12, and that would work. 0 plus 12 is 12. You could have X be 1, Y be 11. 1 plus 11 is 12. You could have X be 8, Y is 4. 8 plus 4 is 12. This line stands for all the answers to this equation. Okay? Well, so there's no answer to that just yet until I give you a second equation. Two numbers whose sum is 12, but whose difference is, I don't know, let's say
4.
0.
8.
6. Now, and I know you can do that, most of you, or some of you will be saying, I know the answer to that, and I don't care, because there'll be ones where you can't just do it in your head. To know how to do this is kind of exciting and fun. What equation can I make from this? Two numbers whose difference is 6, using these same letters. Two numbers whose difference is 6. The word difference means what, Sam?
Subtract.
So what would I do?
X minus Y equals 6.
X minus Y equals 6. Again, what form is this equation in, Zach Rice? Standard, so I can use x, y intercepts as I have done many times in my life. What are my intercepts for this new line? X equals 6. Y actually equals, right, because it's negative y equals 6, y equals negative 6. Now here, lo and behold, the beauty of mathematicos.
Where crosses? Where crosses?
Oh yes, listen to them go.
Yes.
These two lines, try and get this right.
Wait, why is it down there?
Why is who down there?
6 and 6.
Isn't that what
9
negative
and
6 is?
3.
Again, I can only do this so well with what I got to work with here. Okay? This green line is all the possible answers to, when you subtract two numbers, their answer is 6. For example, if x is 6, y is 0. If x would happen to be, look at this, if x happens to be -4, what's y? -10. -4 minus a -10 actually gives you 6 because the negative becomes positive. This green line is all the answers to this. But what we're looking for, Zach Rice, we're looking for the place where those two lines, oh gosh, we're looking for the place where those two lines cross because that place solves both of them and is the answer to both of them. In which case, the answer to this, two numbers whose sum is 12, whose difference is 6, would be 9, 3. And maybe you could do that one in your head, but you can do all sorts of different problems with that if you write the two equations and find where they cross.
That's fun.
I know, I gave you, this was just a blank piece, Charlie, so I could give you blank stuff. Okay? Oh boy. Let me give you one. Let me give you a problem and see if you caught on to that. And I'll try it something. How about this? Find two numbers. Find two numbers whose, let's make this harder so you probably can't figure out, whose sum is, I don't know, let's go a negative number, whose sum is -8 and whose difference is 4. I just forgot the word difference here, sorry. Whose difference, I'm hoping this works out, I kind of just thought of this in my head, so write the two equations with that, and then graph them and see where they cross. Oh, it's got to cross there somewhere. Two number whose sum is -8 and whose difference is 4.
If it's negative, the -8, put it on the
That
bottom.
negative x is -8, y is -8, yeah. And both are negatives. I hope it works. Does it come through out? Sometimes thinking the negative numbers confuses me slightly. Alright. I should just grab this thing and put it over here. Just move you over here so I'm staying so far. Still not quite right. Someday. Hopefully the first line you got was that one. X and Y intercepts are both -8. This one's a little different. Second one, you have a y is -4. Be careful with that, because if it's negative y equals 4, you switch those signs there, so you have a point right there. Right there at what, -4, and x equals +4. So, yeehaw, they look like they're gonna cross. Draw your line between those 2 points. And I'm gonna guess that it crosses here. Very good, close. Again, it's harder to find that point right there, which looks like -2, -6 would be your answer. And again, you could write that as a coordinate point, -2, -6. And if you did, again, this is somewhat of an exacting thing. If you're off a little bit on some of these, you're gonna end up with your thing not, and all of them are gonna work out, so, okay, you're gonna get that. Now, for tomorrow, actually, there's only 2 problems that actually give you those words that you have to figure out. For tomorrow, they actually just give you the 2 linear equations and you just graph them. So you don't have to write the equation part. But what you must understand is this. There are 3 different cases that you run across with these linear equation things. Let me show them to you. The 3 different cases are these, and just how many graphs do you have left? You got the 2 on the bottom, that should be all you need. Okay? 3 different cases here. You can have there where, come on, box. Anybody? Rectangle. Oh yeah, let's go with purple, whatever that is. Oh, that's nice. Nice. Well, let's go back. Let's try this again. Here are your 3 possible answers. 3 possible answers. The first one is what just happened in both of our cases, where you get 2 lines that cross. Okay, if the 2 lines cross, if they cross, you get 1 solution. If the 2 lines cross, the place where they cross is the answer to your problem. Okay? What else could happen is that case number 2, if the 2 lines are parallel, in other words, when you graph your 2 lines, they end up looking like this. They are never going to cross, and there's no solution. Okay, if when you graph your 2 lines, they don't intersect at any point, and they're never going to cross, okay, if one of them was like this, just because they don't cross on your graph doesn't mean they won't ever cross. If they're perfectly parallel, they're never going to cross. And guess what the third case is? Sam, you got a guess for me? Your third case, number 3.
A circle.
No.
They
Nope,
cross
they're always going to
twice.
be straight. Nope. The third possibility is that they actually end up being the same line. They cross at one point, they never cross, and the third possibility is that when you graph these, it happens to be the same line on top of the same line. What do you suppose the answer to that is then?
Oh, no.
Well, it's infinite solutions, it is. Just like a normal line has an infinite amount of solutions, if you put one line on top of the same line, every place on that line is a solution, and there's an infinite amount of them because they go on forever in any direction. So when you graph these, okay, keep that in mind. If by some chance you get a parallel lines, no solution, cross, there's 1 solution. If it's the same line, infinite solutions. 3 possibilities for that. So